Good morning, everyone. My name is Alejandra. Thank you for coming this morning, more after the gala dinner. And I want to present this project entitled Unlocking the Biomethane Potential for Dairy Industry Sludges. This project is running in the Microbial Ecology Lab, University of Galway in Ireland. We are working together with the DPTC, that is like the Dairy Processing Technology Center, trying to find alternatives or solutions to environmental problems of the dairy process in Ireland. And you pass in my poster, the 34, you can see some alternatives for the wastewater. But here we are working with the solid waste. Since 2015, were abolished the limits to produce milk or dairy products in EU. And with this, in Ireland, the increase of different dairy products and milk increased a lot. And with this, the creation or the generation of different waste. For the liquid waste, we have some alternatives like the BFA production, and this presentation is focused in the solid waste. More than 60% of this solid waste is disposed by land spreading, but this can generate different environmental problems. The proposal in University of Galway is generate alternatives to reduce the volume of this solid waste using anaerobic digestion to generate biogas and fertilizer. However, some of these solid waste can have a low biodegradability. And for this, we suggest like microwave and ultrasonication to increase the degradability and the final yield of the biogas. And with this, like reduce the total volume of all these solid waste and generate other bioproducts. Here, we start collecting solid waste from the wastewater treatment plants of the different industrial partners. We select the DAF sludge that is coming from the dissolved air flotation process that separates oils, fats, and grease from the wastewater. And we work with the activated sludge. And finally, a mix of both. We did pre-treatment using microwave of this sludge, and later we did the characterization to select the best conditions according with the soluble chemical oxygen demand for the biomethane potential experiments. We evaluate two parameters during the microwave. That was the time between 1 and 50 minutes and temperature between 90 and 160 degrees. Under these parameters of power 900 watts, runtime 10 minutes, and sample volume 15 minutes. We didn't observe, we observed comparable results between the different times. And for this, we select 1 minute that is a lower energy input for the different pretreatments. And the temperature had a more significant effect, and it's for this that I'm going to show a little bit these differences. Here is the first result using DAF sludge. In the first plot in the left, we observed the soluble COD in the different temperatures. We didn't observe significant difference between the different pretreatments. However, 90 degrees increase at 23% the soluble COD and using a lower energy input. Here, the hypothesis is that the fats, oils, and greases from the DAF sludge change from polymeric molecules to shorter molecules, and probably the methane production increased too. And in this slide, I have the activated sludge. We observe here an increase in the soluble COD with the increase in the temperature during the pretreatment. Here, we select 160 degrees because the increase in the soluble COD was 700%. The microwave here generate a cellular releases of the activated sludge with release of the soluble molecules and potentially more methane production. And later, we mix both sludge, DAF and activated sludge in a ratio 1:3. we observed that mainly 160 degrees generate a significant difference in the soluble COD with 103% of increase in comparison with the not treated sample. And this was like the conditions that we select for the BMP. I'm not going to show all the results because it was a lot of different treatments. We take this sludge to do the biomethane potential experiments using two different substrates. Substrate 1, the pre-treated samples, and 2, the blank or no treated samples. BMP 1 using the DAF sludge, 2 activated sludge, and 3 mixed sludge. Under the conditions here, 6 grams of COD per liter of substrate, 37 degrees, and inoculum granular sludge in a concentration of 3 grams of volatile solids per liter. Here's some of the results, not all the results, but here in the top left, we observe the results for DAF sludge. In blue, the no pretreated, and in orange, the pretreatment 90 degrees. The difference between both was not significant. Probably, no, we observed that the pretreatment is not necessary for the DAF sludge. The total solids reduction was the 90%. For the activated sludge in the left, we observed that in gray, the methane production was higher during the using the pretreated sludge in 160 degrees in comparison with the control. However, it's super far of the theoretical methane production of 300 ml of methane per gram of COD, and here potentially we generate under this like more severe condition of pretreatment, potential inhibitory compounds that affect negatively the community and the methane production. And for this, in the last BMP, I'm going to show both in gray the 90 degrees pretreated sludge, and here in orange the 160 degrees, yellow the blank. We observe that in gray the sludge pretreated in 90 degrees present the higher methane production with an increase in the methane of 30% and a total solid reduction of 86%. Potentially this substrate had a better composition because we mix all the organic load that is coming from the DAF sludge, all this carbon, and some minerals or nutrients that are coming from the activated sludge. And with this composition, we observe like more methane production and potentially use this for next phases that we are going to evaluate pilot experiments to calculate the different technical economical analysis and see if it's potential to apply in the dairy industries. In conclusion, using the sludges, DAF sludge and activated sludge from the dairy industries in Ireland, we can mix the sludge in a ratio 1:3, microwave 1 minute, 90 degrees this sludge, to develop anaerobic digestion of this sludge with an increase in 30% of the methane in relation with the not treated sludge. And thank you. I want to say thanks to the DPTC for funding this project and all my colleagues in Galway. And I'm happy to answer some questions.